The key to implement this automation is once you have added your activity at the manifest field, I will use the XML parser to pass the Android manifest.xml field to get the field about the newly added activity and put them into the joyous menu. And through my self-defined log API, all the information will be recorded precisely. I only need to make some minor modification about my source code and put them into the new framework. The modification including deriving from my vActivity base class. This class is derived from the system's activity class, so all of your current code should be work in the new environment. But once you have derived my vActivity base class, lots of convenient API are available now. You can use the log level description to create your definition for different log level. Since using my activity, you will have 10 different levels available for use. You only need to call log level 1 or log level 2 to put the key log information into the SQLite database. During the development, I found out this log level system architecture indeed can do something really interesting. So, instead of just recording and saving the log information, we can use the function to save something else and serving for data analyzation. This is how I implement this idea into my face tracker activity. The face tracker activity is also part of my digital video processing's final project. The general algorithm for this activity is to use some feature value to recognize the first face firstly and track them. During the tracking, get some key value like if the people is smiling or if the eye is opened, and I use this value to deduce the people's current mood. Through my visualizer's architecture, I can record all of them and pop up them in the right side dynamically, then use some graph to analyze the percentage as well as the people's mood change during the period of time. So, this is how I apply the log system into algorithm verification. Besides the algorithm verification, single-step debugging is also a really important technique. But it is kind of tedious to stare at the terminal like GDB to get your debug information. So, I decided to improve them through wrapping the swap function. For instance, if you have a sorting algorithm, take bubble sort as an example. And if you are willing to change your swap function to my swap function, every time when you call it, it will be recorded in a separate file. And when you go to the visualized algorithm page, all the information in the file will be read one line by one line, using the animation to represent it. So it is a better single-step debugger than what you have in Android Studio. The last thing I want to introduce is the Stack Overflow page. You can find when you scroll to the Stack Overflow page, the visualizer has already executed the search operation before you open the Chrome browser and type in something in Google and look through a bunch of Stack Overflow questions. The secret behind it is I have analyzed your log. Of course, not as sophisticated as the machine learning algorithm. I just try to find the most frequently observed keyword and send a request to the Stack Overflow using the API they provided. Perhaps it is not what you want, but don't worry, you can use it as an independent Stack Overflow client. That is, you can search anything you want in the search bar. And the visualizer will fetch the answers, sorting them using the user's reputation and rearrange them in a better format and UI. And through our experience, I think only the top 3 answers are useful. So when you click the answer, I will only fetch the first 3 answers sorted by the voting and filter out the useless information for you. If you are interested in my project, you can send me an email, and any comment is welcomed. Also, I will open source all of my code in GitHub recently. If you have some idea, don't hesitate to send me a pull request. Thank you and enjoy.